All right, this is APBC Calculus. We're doing midterm review, and this is free response 19D, which is a calculator question, although the calculator is not very useful here. So we're asked to show that g double prime of x equals this. And then we're asked, so there's two jobs here, right? And it's easy to accidentally miss one of them. We're asked to show this, which is going to mean we have to find this derivative, right? So we're going to differentiate this and hopefully get that. And then, so that's number one, right? And the second thing I'm asked to do is I'm asked to say if g has a max or min at x equals 0. So, or I'm sorry, not asked if it's a max or min, just asked to show whether it has a max or not. So I will say that if you get bogged down in this second derivative, you could just cheat and use that second derivative to answer the second part of the question. So you certainly don't have to, but you could, right? So I'm going to do this as a product rule, right, when I differentiate. So I'm going to do this as a u, and this whole thing is my v. So when I differentiate, I'm going to get g double prime of x equals u, right? And then my dv is going to be 3 derivative of f plus 2 derivative of f prime, right? So that's u dv, right, u dv. So this is the first task I was asked to do. Plus my v is going to be this whole ugly mess, plus 2 f prime of x, times du, which is going to be e to the stuff times the derivative of the stuff. Cool. So if I distribute everybody, right, I'm going to get a 3 f prime of x e to the negative 2x, and we'll deal with this in a sec, plus a 2 f double prime of x e to the negative 2x. And you might not have chosen to distribute, it's up to you, but this is going to be a negative 6 f of x e to the negative 2x, and then this will be a minus 4 f prime of x e to the negative 2, or e to the negative 2x. So there's only one set of like terms here, and it's the f primes, right? So those two go together. So I get that g double prime of x equals, and then there's a ton of GCF here because I can factor out essentially the e to the negative 2x from all of these, right? So I'm going to combine these two in as like terms, and everybody else I should have a pretty straightforward situation. So I'm going to factor out the e to the negative 2x GCF. And I'm just going to kind of cheat here. They put the f of x stuff first. Well, there's my negative 6 times f of x, right? So that's done. And then I want my f prime. Well, they have a negative f prime. Well, that makes sense because I have a positive 3 and a negative 4. So that's a negative f prime of x, right? And then they have a plus 2 in front of the f double prime, and sure enough, that's what we get. So plus 2 f double prime of x. And there you go. I have shown with the work to do it. So I did the first thing. I have shown that is the second derivative. The second thing I'm asked is, does g have a local max? Well, this is definitely asking for the second derivative test, right? So we already know that g prime of 0 is 0. We know that from part C, because in part C we found the slope of the tangent line to g at x equals 0 was also 0. So I can now use my g double prime of 0. I'm going to get e to the 0, right? Negative 6 times f of 0, which we'll get to in a sec, minus f prime of 0, which again we'll get to in a sec, plus 2 f double prime of 0. All three of these are quantities I know. If I scroll back up for a sec because I'm lazy, I have a 2, a negative 3, and a 0. So if I plug this stuff in, I'm going to get that this is 1 times negative 6 times 2 minus a 3 times a negative 3, and then plus a 2 times a 0. I think. Let's double check that I didn't do that wrong. Oh, sorry, there's no 3 there. Hang on, silly me. As I was right. Oh, giant eraser. Hang on. There we go. Minus a negative 3. So when we clean this up, I get a 1. This is a negative 12 plus 3 plus 0. So I get a negative 9, meaning that g double prime of 0 is less than 0. So when we put these two together, right, we're looking at a graph that is concave down and has a level tangent line. Yes, it's a max. Right, and the reasoning is that second derivative test where g double prime is negative and g prime is 0. All right.